Lens maker's formula. Dear children, if you have command over this, you must get 3 marks out of 35 marks. What I assure you, 3 marks you will achieve if you command over this formula. This is the lens maker's formula. You have written it many times. 1 by f, mu2 minus mu1 by mu1. This is the refractive index of the material of the lens. Mu1 is the refractive index of the medium in which the lens has been placed. R1 is the radius of curvature of first surface. R2 is the radius of curvature of the second surface. This is the normal form, original form of lens maker's formula. Can you infer it? What is this? Why do you call it lens maker's formula? How will you make the lens? That will depend upon the R1, R2 shapes of two surfaces. क्या मतलब कि लेंस का नेचर किस चीज पे डिपेंड करता है? लेंस के शेप पे, लेंस के मटेरियल के नेचर पे. The nature of the lens, material of the lens that are expressed under mu2, mu1, mu1. This is the radius of curvature, means shape of the first face. This is the shape of the second shape. So you have to practice it many times. When you place the same lens in vacuum or in air, mu1 becomes 1. Refractive index of vacuum is 1 or air is almost 1. So this becomes 1, 1. Means the formula becomes mu minus 1, 1 by this. Mu is the refractive index of the material of the lens. So for simple cases, this formula is used. In complexities, means where different media have been given, you can use this. You can see the lens. You are acquainted. This is the convex lens. This is mu2 in your formula, refractive index of the material of the lens. This is the refractive index of this medium in which the lens has been placed. But what I want to put you to remind, O1 is the pole of the first face and O2 is the pole of the second face. Whatever distances are to be measured for this face, you must take it from O1. Whatever things are to be measured for second face, you must take O2. That is the pole of second face. For first face, you see here, first face, this is the pole and this is the center of curvature. This is the radius. You have not to measure the radius from center. You have to measure the radius from pole. Pole is the origin. You know the Cartesian sign convention. On this side positive, on this side positive, this side negative, this side negative. O1 is the origin. So distance is to be measured towards right. R1 is positive. Again, I am going to stress it. Radius of curvature of the first face for this bioconvex lens or for this convex surface, R1 is positive on this side. This is origin. For second phase, for this convex lens, this is the pole, center is here. The distance is towards left. That is the distance O2C2. This is R2. This is the radius of curvature of the second phase. So R2 comes out to be negative. If you do mistake here, you will not be able to find the correct answer. What I said, R1, suppose radius of curvature is 5 centimeter. You have to write R1 is plus 5 centimeter. If the radius of curvature of the second surface is 10 centimeter, you have to take that one as minus 10. So for this shape, for bioconvex lens, this is plus, this is minus. Now come to this bioconcave lens. You can see here, first phase, this is the pole. Its center of curvature is this one. This is radius of curvature. This is towards left. Towards left. That is negative. So radius of curvature of the first phase is negative. Means if radius of curvature is 10 centimeter of first phase, then you have to write R1 is equal to minus 10. For second phase, now you see, this is the pole, this is the center of curvature. This is coming in this direction. Direction means what? You have to measure the distance from O2, not from the center. This is the pole of the second surface. So R2 is positive, R1 is negative. In any lens, if it has been given, this is 5 centimeter, it means R1 is minus 5. If this is given to be 5, R2 is plus 5. So you must mind it in solving question. This question is most important. Question you can see. Most important and most simple. A bioconvex lens has equal radii for both faces. And that radius has been given to be 20 centimeter. What the mistake we do, we directly take the value R1 is equal to 20, R2 is equal to 20. Your answer comes out to be 0. 1 by f is equal to 0. That we do commit the same mistake in solving these questions. Here you see, this is the bioconvex lens. What I said, R1 is positive for this, O1 to C1, R1 is plus 20, R2 in this direction, R2 is minus 20. When you put R1 plus 20, R2 minus 20, mu is 1.5, simply you put, you will get the answer. You see the question, glass lens immersed in some other medium. What happens to the nature of the lens? This is the lens. Material of the lens has refractive index mu2. This is mu1. This is mu1. You go to the lens maker's formula. What is written there? 1 by f is equal to mu2 minus mu1 by mu1. On that part, this is the question. You see in that formula, if mu2 is more than mu1, then mu2 minus mu1 will be positive. If mu2 minus mu1 is negative, it means nature will change. So here, when this mu2 is more than mu1, glass is placed in air. Glass is placed in air. Mu2 is more than mu1. then nature will remain the same. But when mu2 is less than mu1, means the refractive index of the material of the lens is less than mu1, mu2 minus mu1 will have negative sign. So the convex lens will start to act as a concave lens. Nature will change. You can see the figure. Rays are coming. Sometimes questions do come like this. Rays have been shown on this part. What will happen to rays on this part? Under this condition, this convex lens will behave as a concave lens. So rays will go out in this direction, emerging out, diverging out. Convex lens is behaving as a concave lens. But if same thing is placed for concave lens has been placed in a medium where the refractive index of the material of the lens is less than the refractive index of the nature of the medium. For this case, from this figure you can see this concave lens is not behaving as a diverging lens. This lens is not acting as a diverging lens. It is acting as a converging lens. Summary is what? If the lens is placed in a medium whose refractive index is more than the refractive index of the material of the lens, the nature of the lens will change. Convex lens will behave as a concave lens. Concave lens will behave as a convex lens. Means, in normal condition, this lens will give the convergent rays, but for this situation, this will give diverging rays. Concave lens will give converging rays. You can see the question. Refractive index of the medium has been given to be 1.4. Refractive index of the material of the lens is 1.5. So nature will remain the same. Since mu2 minus mu1, 1.5 minus 1.4 will be positive. Nature will remain the same, which is being given by lens maker's formula. When the lens is immersed in a medium whose refractive index is less than the refractive index of the material of the lens, nature will remain the same. Convex lens will behave as a convex lens. Concave lens will behave as a concave lens. You see this question. Refractive index of the medium is 1.5. Refractive index of the material of the lens is 1.5. So this question has been simply framed. What is here? If this is glass, then this is also glass. This is also glass. Here is glass, glass, glass. What should happen? There should not be any deviation. Means if light rays are coming along this, it will not get deviated. It will simply pass. So when mu1 is equal to mu2, this will not act as a lens. It will not converge or diverge. Simply rays will be passed through it. A transparent portion of a medium only.